here and everything. Did we get the notification? There we go, everyone. We are live. Let's see here. Double check it. I think we should be good. I see it. I see it. Yep, perfect. All right. Thanks everybody for coming out to. Hang on, let me turn that down. Oh boy. There we go. All right. Thanks everybody for coming out tonight. We got a little echo there. Every Thursday here at Decentral, we have our EthVan talks. Not too much to report here. We've had last week we had the polka dot night, which was that last week? Yeah, it was last week. Yeah. Okay, sweet. So we have that, and that's coming up in another 2 weeks. We'll be doing that again next week. Perfect. And then we've had some jam nights. Has that been happening here too? I think on every other Tuesday we have the jam nights, and then Monday we have poetry night or open mic night, as we call it, every Monday as well. So lots going on. Next week we're going to be doing a field trip. There is a Stand with Crypto event put on by Base and Dapper Labs, and that'll be held at Dapper Labs, which is over at the new Emily Carr. Or no, yes. What is it? Yeah. What's the new? Yeah, it's the new Emily Carr place. Yeah. So it's over. It's over there. So it's at their offices. It's going to be a larger event. I think Ken is supposed to be showing up for it. Mr. Ken Sim, aka the mayor. Hopefully everybody has signed up for that. If you haven't already, just take a look in. We've been posting it in some social channels. I'll try and post it again in Discord. From the announcements in there. I know they're getting pretty close to full, so if you're in here, I would love you guys to be there. I'll try and post that here tonight to make sure that you're there. That's kind of it. Anything else? Any other things? Announcements, etc.? Actually worth noting as well, Decontrol has made it onto, it's in the latest Giveth quadratic funding round that's put on by Octant and ENS. So they're matching $80K this round. And so we got in, we are, as we're doing education here every Thursday, we are doing what we can here to try and wisen up the Ethereum community within Vancouver and the broader ecosystem who are tuning in with us live. So hello, everybody that's tuning in with us. So if you can head over to giveth.io, you can find that and just search for DCTRL, Decontrol. The Decontrol hackerspace or Clubhouse. And just any kind of donation helps, like $5, $20, anything. Just something even small. I recommend doing 5 at least, because then you get matched for give backs, so that you can actually get you have your chance at winning some give as well, some GIV tokens. So if you donate more than $5. And take a look around at some of the other places that are accepting donations as well, because by donating to other places as well, it definitely strengthens more quadratic funding algorithm. They've got kind of a wild algorithm for how donations can work. But if you can donate to that or donate to more than just Decontrol, it helps the whole ecosystem, and it'll actually get us more matching funding in the end as well. So we're gonna try and do maybe a space on next Wednesday. Are you around for that? Okay, we'll try and sign up for that. So if we can get, we might have a Twitter space with Giveth. So we'll broadcast that as well if we get into that. So every bit helps. Okay, with no further ado, I'll pass it over to Nick here, who's been so kind enough to come and talk to us a little bit tonight here about WAVS and the decentralizing of compute.
Yes.
Alrighty, take it away. Thank you.
Thank you. Thanks so much for having me. I've been coming here a couple weeks now. It's been great. So thanks for being a warm, welcoming community. I've talked informally with a few people here about what I'm working on. So now I'm going to talk formally about what I'm working on. It's called WAVS or WAVS. Still coming up with the name. I call it WAVS. So I'm going to talk primarily about kind of what WAVS is, how it works, and why it works the way that it does. This is kind of my thing that I'm most interested in discussing. Why did we design it this way? A lot of people are trying to do off-chain compute. As far as we know, we're the only ones who are solving this problem in this way, and I'll kind of be here to explain why we think this is the right solution to this problem, and I'll show you a couple demos and then hand off the docs, and then we can go chat and party. My name's Nick. Before this, I did DAO, which is still a premier Cosmos ecosystem DAO tooling. I joined my co-founder, Jake Hartnell, who founded now this project, and it's been great joining the Ethereum ecosystem, learning more about Ethereum. Lots of cool, smart, fun people, which I love. And I took on a role as head of product there. A little bit about us. We're called Layer right now, and we're about to change that name because it's very confusing with Layer 0. We're post-seed, pre-Series A, and we're going to be doing our raise in what is this? So Q2, we're going to be doing our Series A raise. But we have a product. We're trying to get developers onboarded. We're launching our builders program really soon. So consider this the unofficial start of our roadshow. We talk to people about the product we have. So a little bit about our problem. So smart contracts are not what we would call intelligent. They have very limited compute, limited really by the limitations of Ethereum itself, an EVM. They're not aware of things that are happening off-chain. They're not really aware always of things that are happening on-chain. They have limited awareness of their own state, and they have limited access to with the full world of compute as a result of their reliance on the EVM. Our solution to this problem is to combine WASI, or WASM, WebAssembly, with AVSs, what we call WASI AVS, or WAVS. So we're producing a WASI runtime for building AVSs on top of EigenLayer. What is the difference between WASM and WASI? I know a lot of people have heard of WASM. Fewer people are familiar with WASI. So WASM is kind of like the vehicle. That's the code itself. You can think of it like a .wasm file. That is the bytecode that can be run anywhere. You can take your Rust code or language of your choice. We're a Rust shop, but we support now Go and JS as well, Python coming soon. But you compile these languages down to this WASM bytecode, and then you run it in a virtual machine, which is this kind of WASM standard virtual machine. Now, WASI provides a way for WASM to communicate with system-level functions. So if you're familiar with Node.js, Node is to the V8 JavaScript engine as WASI is to WASM. It provides, file bindings. It provides, all these system-level bindings. It provides network I/O and all these other kinds of things like that. So you can do all these network calls. In time, you can do GPU. You can do file storage, and you can talk to the EVM in this really rich way. And the best part is that it has this really highly composable architecture, which allows us to make what we call intelligent protocols. So what do I mean by intelligent protocols? Well, let me skip ahead here a couple slides. So the way we envision this is that you have all these different components that are using a mix of on-chain and off-chain compute, and you can wire them together in this really flexible way. So you have this LLM over here, you have this Oracle over there, you have another LLM over here, and you just have this flowchart that kind of wires them together. And you can compose these together into what we call, these kind of, again, intelligent protocols. All are economically secured with real staking and slashing and rewards. And all of the compute is verifiable on chain. And I mean actually verifiable, not like, hey, I run it on my server, trust me, bro. This is the real compute, I promise. And we'll talk a little bit more about how that's done. So I think that one of the things that we're really liking to talk about these, why WASM? So you may be familiar with some other projects out there, probably won't name them on the live stream, that use, for example, Docker containers or Linux virtual machines to accomplish a similar effect. So here's a quick rundown of the different kinds of performance characteristics between the VMs and WASM. And I want to say, by the way, just steelmanning the argument, it is very tempting, I think, if you're trying to solve this problem, to say, I'm going to use a Linux VM. You've got really familiar environment. Developers know how to use, this Linux, kind of environment. There's really good tooling around this to make it reproducible. There's Docker. There's Nix. I run Nix OS. I'm a fan of these things myself. The reason that we don't think that this is going to be a long-term performant enough solution comes down to two things. So the first is the size of the containers or WASM. And then the second is the startup time. So by the way, for both of these, you really have bare metal or basically bare metal. I think that there's this common misconception about virtual machines in general that you take a performance hit. These days really you don't, especially with Docker you don't. You're getting bare metal performance with both of these. It's not about the runtime performance. What matters more is that you get these, with containers or with VMs, you get like best case 10 megabytes, but usually it's like a gigabyte or more to get this Docker container loaded up or this VM loaded up. And the startup time, best case, is a matter of seconds. And we can talk like 10, 20 seconds. Right. So let me put it to you this way. When you're looking at this graph and you see there are all of these different services running, you're left with two options as an operator, someone who really runs this compute. Either you are left running all of these different Docker containers, VMs at the same time, which is going to be very taxing for you. It's going to cost you more, and you're going to demand more money as a result. Or you're going to say, I'm only going to spin these up on demand. Because some of these services run all the time. Some of these services run once a year. So the ones that run all the time, OK, they're running all the time, right? So the overhead should be as low as possible because it's annoying. The ones that run once a year, well, when they do run, you want it to be fast. You don't want to be waiting 20 seconds for the VM to start up. That's a horrible experience, right? So WASM gives you both of these things. First of all, very, very lightweight packages, no big deal to keep them running. And if you want to go and kill them and spin them up again, it's like, here we put milliseconds. This was before we actually built, the current version of the product. What we find is actually it's often under 1 millisecond that it takes to start up these services. It's really, really very, very performant. And you don't lose any, system interaction. You don't lose any, kind of performance there. You even gain a little cross-platform compatibility. Operators run different architectures. That can be annoying with Linux VMs. We get rid of that completely with WASM. OK, so that's why WASM. And even the founder of Docker is excited about this technology. He said basically if WASM and WASI existed in 2008, we wouldn't have created Docker in the first place. That's how awesome WASM is. So it's not just us that we got super WASM pilled. This really is, I think, a good way of solving this kind of portable problem. So I have a couple demos to show you, but before I do, I kind of want to give you a sense of. Oh, I must have hidden the slide. I want to give you a sense of what's going on here. So let me unhide this. So this slide kind of gives you a sense of the architecture that we use here. Oh. So what we have is basically, we have Ethereum. OK, that's your L1. Then EigenLayer kind of allows these L2s on top of it that still inherit all the economic security from Ethereum. So on top of that, we call I think EigenLayer also uses this terminology, an operator. So the operators run AVSs. Now, the biggest problem with AVSs today, and you may see some discourse around this, it's hashtag discourse, but restaking is restaking is overhyped, there are no rewards. That is a legitimate problem with restaking. One of the things we were trying to solve, not for our testnet deployment, but probably for our mainnet deployment, is that you should actually be able to align economic incentives with your operators. If you're deploying an AVS, if you're deploying an LLM that runs off-chain, you ought to be able to stake to it. You ought to be able to get rewards. When people are paying to use that service, people who stake to it ought to be able to get those rewards. And if an operator is doing something nefarious, lying, giving bad output, they ought to get slashed, right? We have all of the same kind of proof-of-stake kind of concepts that apply at the L1 layer should also apply to all these operators who are running these AVSs. All right, so with that kind of architectural caveat out of the way, let me show you a little demo. So the demo here is let's say you have a bouncer to your Discord service, right? So you want to make sure that people kind of pass the vibe check here. So in order to do this, we have a little LLM that does the vibe check. Now, this LLM is running on WAVS on various operators. Okay, so the outputs from these operators are kind of being coalesced in real time, added to the block. We can really see that the response is the real response. Or alternatively, we get access to the model, and we can run that model in the browser. Because again, WASM runs in the browser. So if we have access to some known to be good model, we can run it in the browser and achieve a similar result. So what's happening here is that someone wants to get access to this Discord server. So they're saying, hey, look, I need to check your ID, make sure that you have this NFT. You connect your wallet, upload this NFT. And it's OK, well, I need to see what your favorite ocean is. So you say, I love the Pacific. And it's OK, cool. You pass the vibe check. You can come in. Now, the idea here is it's kind of a dumb example, but this could be, this LLM or the prompt that hydrates this LLM could be controlled by a DAO. Could be subject to DAO governance. So imagine a DAO that has some governance say over the prompt that does the vibe check. And not only are you manipulating this prompt through governance, and governance is responsible ultimately for this prompt, but the DAO can also then deploy that LLM and see that that LLM is being used in the way we think we're using it, that it's the right model, and all of that. So, to me, this is like a real example of kind of like verifiable AI. A lot of people bandy this kind of term about, but, in my view, this is as close to verifiable AI as you could really ask for. Mentioned also some of this restaking stuff. So again, people say, oh, there's no real restaking because there are no rewards. So what we're showing here is what we call commitments. So you can make commitments to these different AVSs. One here is this like AI bouncer that runs on top of an LLM. And you can kind of see like who commits what to it, what assets they commit. And on top of that, there's some APR. This is dynamic, of course. The APR might change depending on how it's used, who pays, what they pay. And again, if any one of these operators, you can see on the right-hand column here, these different operators may all run the same AVS. I don't know if you can see yeah. These operators all run the same AVS. So again, we have 3 people running the same thing. That redundancy gives us this verifiability. If one of them gives us a different output from the others, we slash them. So again, that's the slashing economic security mechanism. Here's a little example of how you might make an AVS. So you just type in your AVS name, upload your WASM script, and it really is as easy as that. Okay, you verify that the WASM is good. You instantiate it with the operators. The next thing you know, you've got your AVS set up. Here's an example of one in use. So this is a simple one that squares a number. So you just like put in your number here, submit it, and then we sign, execute WASM, queues it up, and then we wait for the operator to give us the response back, and there we go. There's our answer. So that is more or less my entire talk. If you are looking to do any kind of on-chain stuff that requires off-chain compute, that includes any kind of AI on-chain, or just you need to know what the weather is in Vancouver. Okay, I truly believe that this is an easy way for you to do that. You can write up a script in Python, JavaScript. Again, we use Rust. We recommend Rust, but you use whatever language compiles to WASM that you like, and you give us the WASM bytecode, and you can go ahead and run it on chain. So the last thing I want to show you before I wrap up here, and I hope I made this snappy enough. So first of all, you can find us online, waves.xyz, WAVS. We have this splash page. Okay, again, we're getting rebranded soon. This is all changing soon. This is just our splash page for now. Actually, April 1st, we're going to launch the product for real. So new brand, new us. But you can go ahead and start building. Okay, we have these docs here. So this is just docs.waves.xyz. So please feel free to play around, build a service. I'll distribute. I'm Elshow on basically every platform, Telegram, Discord. And I'll join the, I actually haven't joined the DCTRL Discord yet, but I will. And so you can reach out to me on this. If you have something you want to build, just go ahead. We have a little, really kind of simple demo here that walks you through building a simple AVS. All the AVS does is like check a price on Bitcoin price on CoinMarketCap. I think this is actually a pretty cool demo because you can't really get that information, in any other way, and it's just a really simple thing to show how this stuff works. So, 4-minute little YouTube video will show you how to spin this up yourself, and I think once you go through that demo, you'll be pretty convinced that this is like a nice way to build off-chain services with off-chain compute. And I think I'll kind of wrap it up and take questions there. Just a few other things to kind of head off any questions. We don't have GPU support yet. We are working on it really hard. That stuff is actually upstream of us in WASI. So we're working hard on integrating that, but it's not quite done yet. A lot of people also ask about TEEs, trusted execution environments. That is also not done yet, but we do have a launch partner who's interested in this, so we're prioritizing it. And I'm highly optimistic it will be done soon. And like I said, we're working on Python support. To me, it's kind of a holy grail because you know a little Python, suddenly you can write cool on-chain services. So that will also be done again soon. PM. So that's all for my presentation. I'd be happy to take any questions and hear any comments or feedback.
Got a couple of mics out there if we need.
I hope you hear me.
Yes.
One.
Yeah.
I just have a pretty simple question. Will you try to implement any KYC system? So if I understand it correctly, you will let people run Docker in the browser.
Mm-hmm.
And will you, we all know that people are sometimes trying to use all VPS for not really good things. My question is, will you try to implement any KYC protocol or something like that?
So there's no Docker, to be clear. No Docker involved. Yeah, but WASM does run in the browser. And as far as KYC goes, so there are a few things in the Ethereum ecosystem that do some kind of KYC. So again, I know we're being live streamed, but can't talk about all the stuff, and they have like signed the MOU that we talk about it publicly. But the short answer to your question is like, I think KYC is a really attractive and easy use case for our tooling. And beyond that, like there's good institutional money out there with the KYC use case. I think that when you try to solve the KYC problem, you find yourself resting on a variety of different data sources. And the problem that you start running into, this is kind of a philosophical answer to your question. The problem that you start running into is like, because you're relying on often proprietary, closed, or pay-for-access databases to do the KYC itself, occasionally, even if you have a decentralized compute layer, you'll find yourself back in a trust me bro situation, because ultimately you're still relying on the KYC provider. So I think that a good solution would look like, okay, anyone has some free time on their hands and a bit of like, kind of financial Rails knowledge, if you can afford, you can get kind of the VC money to afford a couple of KYC providers. I think what WAVS can do is allow you to cross-check multiple KYC providers at the same time. And occasionally there may be discrepancies, but I would say in most cases, if you see both KYC providers give you the same all clear answer, that person's all clear. And I feel the simplest way to represent this would be to hand that user a soul-bound NFT. You can imagine this like a verified checkmark, like a blue checkmark like Twitter used to have, or Twitter still has it, but you know what I mean, like an actual blue checkmark. Yeah. So something like that I think would be a nice, cool use case for WAVS. That said, I think that even if you are just trying to use a traditional KYC provider to get this information, getting that through WAVS is still going to be easier for you than getting it through a traditional on top of EigenLayer AVS for a couple of reasons. So for one thing, you can build the language you already know. You do not have to rewrite all of your stuff in Solidity. And second, anyone who has tried to build an AVS on top of EigenLayer will attest to this. It's actually a lot harder than you think. Like the surface area is pretty large for these things. A lot can go wrong, okay? And especially when you're dealing with KYC, where potentially confidential information is getting passed around. I personally would prefer to do that through WAVS on top of a TEE. That said, I think that privacy on chain is very, very tricky. I know ZK is hot, but ZK and KYC there are tensions between the goals of these two, of the technique of ZK and the end of KYC at times. So I'm convinced that we have a good KYC solution here. Now, all that said, it's not like the first thing we're working on. But yes, I think this is something you could use to KYC.
Yeah. Okay, thank you.
Yeah. Sorry for the long ass answer.
Hey Nick.
Yeah.
Thanks for the talk. Can we go back to the demo where you did the square thing? So can you kind of walk me through? See a lot of different things happening. There's like this app that I'm interfacing with. There's a transaction that's happening. Can you kind of walk me through step by step the different components?
Absolutely.
And what specifically is WAVS?
Yes.
Versus.
Okay, great question. All right, so this app that we're looking at is a WAVS operator services dashboard. We don't know what to call it yet, so we just call it the dashboard. So what this dashboard shows you are a couple of things. First, and most salient to this demo, it shows you what AVSs are available. So these are AVSs where when you have this big library that you could use to build your app on top of. I take this KYC one and I take this LLM one and then I stitch them together to make my app, right? But this is a nice visual way of seeing what AVSs are deployed and using them. So let's say there's the Square AVS that's out there and you're like, perfect. All I need to do is just square these numbers, babe. So I'm gonna click on that, and what that takes me to is this new view. So this view now shows me a couple of things. First, it shows me what kind of economic security is committed to this AVS. So you can see, I have some ETH, USD, and DAI. So this, people pronounce it DAI, right? I always pronounce it DAI. I don't know if it's DAI, but I pronounce it DAI. All right, so ETH, USD, and DAI is now committed to this AVS. That provides us some economic security for this AVS. Now, you can see it right next to that, the operators. These are the people who are actually running the AVS. So when you square your number, what's going to happen is that it's going to go off to these three operators or some subset thereof. They're all going to square this number. We're going to, they're going to send back the answer with their signature. We're going to collate those signatures, write it to the chain, and reward and slash is necessary for right and wrong answer. And then below that, you see the task queue. So this is everyone who's ever used this AVS. This is like a little block history of AVS calls. So you can see when they were added, when they were finished. You can see it was pretty quick AVS. It happens in like under a minute, obviously. So now let's check out what happens when we use this AVS. So to do that, we go to demo. So that allows your AVS provider to give a little view that allows you to graphically kind of interact with your API. So we're going to provide a nice framework to allow you to publish these pretty easily in a nice component library to make this really stupid simple. But basically the Square AVS exposes this demo, and the demo is exactly what you think. Amount, you enter your little number, press submit, and it'll square that number. So to test it out, I'm going to go enter my number here, 15. I'm going to press submit. Now let me pause again. Oh no. There's no really great way for me to scrabble in this. All right, so let's just be patient and get back there. Okay, so I enter my number and I press submit. Now, what happens first is that I validate the input. That can all be done without submitting a transaction, because actually we know the WASM. We can even run that WASM in the browser. Hint, hint, nudge, nudge. See that the input is what we think. Now, there's this task submission policy. So to be honest with you, this is an implementation detail I'm not that familiar with. I have to kick back to engineering to learn a little bit more about what that is. The salient part, though, is that there is a fee. So I pay some amount of money in order to get my Square number back. This is important because, first of all, it incentivizes the operators to run the compute. So obviously, 0.01 layer is probably a pretty low amount, made up token for testnet purposes. But you can imagine if you're running an LLM and you're doing tons of inference, this number gets a little higher, and it approaches these kind of API call kind of amounts of money. So that money goes to the operator. It also goes to the stakers who provide that economic security. Now, again, I cannot overstate this. Economic security is important because it allows us to verify the compute. If we don't have economic security, there's no way for us to slash dishonest people. And the whole reason why we're doing this is because we think there may be mission-critical off-chain compute use cases where you have an incentive to front-run. You have an incentive to do MEV or similar, right? So in order to prevent these kinds of use cases and make this compute verifiable, we add this economic security, and that allows us to slash people. The flip side of that is that we also have to reward the stakers. So this task creation fee goes to the operators and to the stakers who provide that economic security. So that is the purpose of this task creation fee. Now, after we retrieve that task creation fee, we queue up the thing in this kind of WASM kind of queue that is across all of the operators. And the operators then, we wait for the, oh no, I've done it again. This is the one thing I didn't want to happen. So after the thing is queued, the operators have their own queue. They work through it. When all of the operators are ready to run, we get a response here that allows us to execute the smart contract. This is where we actually pay the fee. And if you zoom in here, I think it's probably pretty hard for you guys to see, but I've done it again. But you can see the input and everything in the schema of the transaction. So then we wait for the operator. Operators run the thing, and then they give us back the squared number.
Cool, thank you. Why an AVS on EigenLayer rather than your own chain?
Great question. OK, so first of all, I think that EigenLayer has done a lot of infrastructure that we like. So a lot of the stuff that has to do with restaking, it's not necessarily think about it this way. Say you're a VC, and we're coming to you with a seed round. And we say, hey, we want to do this thing, and there's all this cool stuff. It's not like this didn't occur to us, right? And the VC, who's obviously very literate in this case, may reasonably say, OK, but hasn't Eigen already implemented that? And we'll be like, yeah, but they haven't done the staking yet, and they haven't done the slashing yet, and we need to do all this stuff. And it's OK, just do a PR to Eigen. What we really want to see is that you have the thing that's novel, done, and done well, and that Eigen, if Eigen is convinced enough that they start implementing slashing commitments as a result of your great product, then we're convinced. Then you're on your way to a Series A. So we kind of took that to heart, and I think that the spirit here is look, Eigen is a great launch partner for us, and we've had actually a fantastic relationship with Nodder in particular, whom some here might know, who's been a great, I think, evangelist for our tool. And also, we have a multi-chain vision, so I didn't really get a chance to talk about this much. But we really envision this as something that happens not only, oh, there's a WAVS deployment on all of these different chains, but you can create real economic security across chains, and you can create intelligent protocols that span multiple chains. We think someday, probably, our tooling will actually be its own L2. And we might even implement like the best ideas from Cosmos, which in my opinion is like IBC. So I think that an L2 that supports IBC and WAVS, suddenly you connect to all of the Cosmos ecosystem IBC supporting chains that also have CosmWasm. Okay, one of our co-founders also developed CosmWasm, which is why the WASM thing. But now you're really cooking with gas. Like you can do all of these cool, smart things across multiple chains. Like that is the long-term vision. But I think we have a crawl, walk, run kind of mentality about this. And also, like I personally, even compared to some people on the team, are of the mind that getting people in the ecosystem excited and being like, oh my God, wait, this is so much better than what I was doing, that's a great first step. And sometimes we have to make like, not sacrifices, like more like, we have to, like, it's great to be demonstrating that we're interoperable with what already exists, even when that means accepting some limitations. And I think what we get in return is a focus on the thing that really is the novel problem.
Thank you.
Sorry, I keep giving long-ass answers.
Any other questions?
Keep going.
Let's do it.
Play your token.
Yeah.
Yeah, how are you thinking about this token? We love to speculate on tokens.
We love that.
How am I earning tokens? How am I selling them?
Totally.
All that stuff.
Yeah.
How are you thinking about that?
So I know we're streaming right now. Look, I think this is like a hypothetical and abstract conversation, obviously. Like, how would you implement this in a way that aligns incentives? And I keep like harping on this, but the problem with a lot of the decentralized compute stuff you see is like, either it's trust me, bro, or you have to get a lot of people to run it, and then you really have to make sure incentives are aligned and the operators are happy. So I think the question you want to start with is like, what keeps the operators happy? And operators are simple beasts. Love them to death. We have good relationships with them, but like, how is this going to make them a little extra money on top of what they make from just being an Ethereum validator? From restaking on EigenLayer, they've already gotten all their eigen drops. We have to give them something, right? So what we think makes sense are kind of two things. So first, there is a restaking token. So this restaking token is something where like you stake this token, you are going to get rewards from the economic security that you provide. And the second is a utility token. So utility token, maybe it's not called the layer token because we're not called layer anymore. We call it the WAVS token, right? So WAVS token is just a simple utility token. That is what the operator fee is denominated in. When you run your service, you burn your WAVS token, or not burn, you give your WAVS token, to the operator and to the restakers to give that economic security. So, whether WAVS or this restaking token or whatever, how these interact, like maybe that's more of like the design space we're talking about. But if I'm thinking about like the schematic components, I would say there's a restaking token, there's a utility token, and the two accrue value. And also, I would say that restaking token may have utility or like may be able to do things beyond just like the wave stuff in the future, depending especially on this kind of like multi-chain vision.
Cool. Could you have built this using Docker instead of WASM?
We could have. I think what we would have seen had we done that is, first of all, the Square demo would have either taken forever because you're waiting for them to start up the Docker container, or the operators would have been like, bro, I need to run an entire Linux VM just to square like a number. Like, this is dumb. I'm not doing this. But when we say, hey, there's this thing, it has like a millisecond startup time, it takes like under a megabyte, and the compute, whatever it is, whatever the overhead RAM or compute is, or storage or whatever, I promise you're going to get remunerated. And if not, like, you set the price, don't worry. And they say, oh yeah, for sure, signed. So I think it's like, could we have done it? Absolutely. And in many ways, probably would have been a lot easier to do. And in fact, there are, again, not naming names, but there are projects that have this and have these proof of concepts done, kind of as like a co-processor kind of mode. But I think what those projects are going to run into, like if I had a little crystal ball, I'd look into it and ask this question. But like, the operators running this thing at some point are going to get fed up. Like, they're not going to really see the benefit of, economically, or if they do see the benefit, it will be on the backs of the people running the code who are going to be like, sorry, it cost me what to do an LLM inference? So, that's kind of the answer there.
Is WASM still, WASM's still a little not mature. unmature compared to some of the other technologies out there. Do you foresee any issues there?
I think WASM's mature. I think WASM is mature in the sense that like everyone who uses a lightweight portable VM either uses WASM or V8. And we're not doing V8 because we're not doing a JavaScript VM for this. And like WASM is pretty battle tested. And I think also like when it comes to stuff in Web3, security really is paramount. And when I think about like the attack surface area of something like WASM has had the best audits in the world. Like Trail of Bits has done a WASM audit. Like, Trail of Bits is, in my opinion, like the best auditor out there. They wrote, this is kind of an aside, but they wrote this incredible paper called like How Decentralized Are Blockchains or something like that. And they found these like incredible, like, in Bitcoin, you talk about like a 51% attack. They found it's more like a 10% attack because you can do all these weird timing things and like, the way that mining pool power fluctuates throughout the day. Like they're really, really good. And like if they can't find issues with WASM, I feel confident using WASM. And now compare that to like a Linux VM where like suddenly your attack surface area is like the entire Linux stack. Like there are literally critical CVEs and SSH still. That's crazy town. And, I think it's not a big deal when we're just like messing around doing square root stuff or they're just these kind of like silly, not silly, but like, not super widely used apps. But once you start adding in that economic security layer, and like maybe we'll be the first, maybe we won't be the first to add in the economic security layer, who knows? But like once you add that economic security in, suddenly the TVLs in these, you get like, you get 10 million, 20 million, $1 billion TVL in these ADSs. People are now suddenly going to be incentivized to find lots of Linux vulnerabilities. Or like people are holding on to, like North Korea has so much Linux ODE probably that they're just holding on to just in case. And if suddenly there's a lot of TVL in a Linux VM, we will see that, And it may be that they also have WASM ODEs. Like I'd rather get popped doing WASM because I thought it was safer than get popped doing Linux stuff knowing that it was unsafe in comparison, especially when I take into account like the performance considerations of spinning up a Linux VM. Thanks for the good question. Hard questions.
Anybody else? All good? Okay.
Thank you guys so much.
Thanks again.
Yeah,
another round of applause, please. And just another reminder, we're not going to be here next week. We're going to the Stand with Crypto launch, which is at the, I believe, the Dapper or the Flow office, which we will post about on our social channels next week sometime. See you there, hopefully.